Hi, we are Team Cyclopes and Trinxue, producer and programmer.
I'm Jun, designer.
Shen, the programmer and designer.
Being the artist.
The old artist.
So our advisors are Scott and Salvador, and our client is Dr. Earl Hian, the Associate Professor and Neurologist from National University of Singapore. The goal for our project is to encourage medical and healthcare students to have a better understanding of the difficulty of their patients with abnormal vision and empathize with them. Our target demographic is medical and healthcare students. So before Carter's, we did several research on various symptoms, and we finally chose 3 of them as our primary symptom to develop our game ideas. We give each of them a unique urban area scenario with a different gameplay. We also developed 2 fast prototypes to see if the gameplay and symptom work well with each other. During quarters, we had a lot of feedback. One important feedback is that we should have a better understanding of our patients and their symptoms. Another issue is that we should simplify our game ideas and make them more realistic. According to the feedback, we had 3 big changes. The first one is that we added augmented reality experience. The second one is that we refined our virtual reality game ideas. And the second one is that we did more research and playtest.
So we have developed an augmented reality experience in addition to the VR experience. We got inspiration from this Samsung Gear device. With such kind of device, the players would be able to see through the camera of the phone with certain eye symptom effects that we created. Such AR experience would enable the players to experience their daily life activity by interacting with the real world in an intuitive and realistic way. So we have AR experience with more daily life activity and VR experience with situations that might be dangerous for people to try out in the real life. In this way, the AR and VR experience are mutually complementary, which will give the players the full view of the patient's feelings. We have done much research to find out a better solution to the hardware. These are 4 key requirements to provide a good AR experience. We need wide-angle lens, stereo vision, large display, and high resolution. First, we test the AR experience with this Google Cardboard. We can get high resolution and large display from the phone. However, it doesn't provide a wide-angle lens and won't be able to capture stereo image. Then we came up with this Poppy 3D, which could expand the angle of view and create the 3D vision effect. However, we found the view and display are still quite limited. So finally, we came to this device. It is a combination of Oculus and 2 webcam, which has a lens of 120 degrees. And we could easily achieve a high resolution and large display with Oculus Rift. We have implemented 5 different symptoms on the AR device. First, with tunnel vision, one could hardly see anything except for the limited field in the center. With red and green color blindness, one could only see blue and yellow. And diplopia, or say double vision, that's one will see everything in double. And oscillopsia means one will see everything is shaking because his eyeball is shaking. Migraine auras, this rainbow-like spot would appear with a sudden dramatic headache. Our artist has designed these simple, clear icons that represent the typical features of each symptom. And we are also thinking about possible designs for the AR experience. It could be like an activity book that would guide the players to accomplish some tasks and help them better understand those symptoms. This Ishihara test for color blindness could be an example for the task.
And for the VR experience that we already have planned, we are currently focused on the driving and chasing activity. So as planned, we designed and developed the driving activity with tunnel vision. that the player needs to drive through an urban area with a limit of time, while it needs to avoid crash into other car cutting into traffic, pedestrians who are crossing the road, and maybe passing other cars at some time. So the art assets for the urban area has been done, as well as the implementation of the driving simulation and the tunnel vision filter. We're currently on the phase of iterating current build and try to improve our experience based on the playtest, like finding a suitable controller for our game and tweaking parameters and level designs to make the driving experience more convincing and challenging. The other VR experience that we're currently developing is the chasing activity, which the player will chase after his pet dog in a similar urban environment setup with first-person perspective, double vision, and tempo run style. We have finished the level design. It's currently under implementation. One biggest challenge for double vision is to judge the position and distance of objects. So as shown on the map, we have put a lot of obstacles like trash bins or crowd of pedestrians on the player's way that he needs to avoid. At the same time, based on the playtest feedbacks and our clients' feedback, we have also moved on to introducing more symptoms to the current VR activities, rather than one symptom for each activity, namely the tunnel vision, the diplopia, color blindness, obsilopia, and migraine aurors. So different symptoms for the same VR experience will share similar game mechanisms and setups, but will face different level design and challenges. For example, the tunnel vision in driving will face the challenge of avoiding pedestrians and car entering the traffic, while diplopia, also known as double vision, will face a challenge like go through roadblocks, which has just minimum width that the car can drive through.
I'll speak about research and playtests we had so far. Since Clara's presentation, we have communicated with our clients more actively and received data on symptoms to design gameplay and simulation. To know more about patients' lives, we tried to set up interviews, but we were unable to talk with them in person due to privacy issues. Instead, our client talked to his patients and asked some questions on our behalf. In addition, we researched online and could find very useful materials about patients with eye disorders. Before HAVS, we conducted one playtest with ETC students, another with members of our target audience. Our goals were observing how players felt about abnormal vision we simulated, if the experience resulted in players better understanding patients, and how they responded to driving game mechanics. Let's watch playtest video first.
I think that's absolutely true because, first of all, learning about them, and then second of all, being able to see it, seeing how these patients are just having a really hard time.
Definitely. Myself, I'm a public health area master student. I really have more understanding about like color blindness and other vision problems.
Definitely, especially if they, I would reinforce it if they had patients that had the experience. Just because it's hard to like hold on to anything tangible if you're just aware of these things.
Yep, that was our playtest video. For the playtest of AR experience, we observed that players enjoyed experiencing each symptom in a realistic way and interacting with a strange-looking world. According to our questionnaire response, we could see that our game had educational impact on players. 16 out of 17 students mentioned that they learned more about abnormal vision conditions, and all 17 answered that they had a better understanding about the patient's difficulty from playing our experience. For the first playtest of VR experience, we designed driving activity only for tunnel vision, but found that tunnel vision was not challenging and engaging enough. Also, some playtesters wanted to drive with other abnormal vision conditions as well. Based on their feedback, we decided to test driving mechanics with 5 symptoms we already have simulated. So during the second playtest with medical, pharmacy, and healthcare students, we let them drive virtually with all 5 symptoms. Players seem to enjoy driving with various symptoms and comparing differences. Also, every playtester indicated that they learned abnormal vision conditions and patience difficulty after playing our experience. Among 6 playtesters, 3 preferred AR due to its realistic feature, while the other 3 said VR is better due to its gamified experience. We also got feedback on what they didn't like in each experience. For AR, the lack of any actual tasks resulted in playtesters wanting more structure. For VR, the current gameplay we implemented was not engaging enough. Now Bo will talk about what we will do next based on what we learned from the playtest.
Thank you, Jimmy. So let's take a look at what we are going to do next. For AR part, we are going to combine Oculus Rift and webcam to let players experience the real world experience. And we will design more tasks for players. Also implement a set of UI in this program. For VR part, we are going to work on finishing the tracing prototype and also design more levels for each symptoms. And last, we are going to polish the urban environment more. Please take a look at our schedule. We plan to finish all the actual production on week 13, and after that, we are going to polish more on our project. And also, we will conduct a playtest before soft. To summary, we are creating a virtual experience that simulates different abnormal vision with AR and VR technologies. And we hope this project will help people to understand more about the eye symptoms. Thank you. And now we are open for questions.
Any questions? Yes.
In some ways, it seems like a lot of work to support both the AR and the VR. Are you worried that it's too much work and that you'll spread yourself too thin?
Well, actually, the AR part, we have done the technical part, so there's no programming works on that. It's all about designing work. So, and after VR designers have finished with the design on the visual part, which is almost done, then on the rest of semester, the designer can work on the AR experience design, like those task guidebooks, rather than, and then the programmers can focus on the VR experience development, so it's a reasonable schedule for our project.
Yes.
So when you talked to the medical students, you asked if they believed they understood these experiences better, having these eye conditions. Is that the way that you're going to measure whether or not they learn anything, or are you going to try to are you trying to measure whether they learned something, whether they feel like they learned something, whether they feel a sense of empathy and identification, and how are you going to make that more precise in the second half of the semester?
I think major goal is making them understand the patient's symptom. To make them understand, we try to give them at least educational impact, like letting know what all these symptoms we are simulating, but main goal is not giving them a knowledge, but like trying to make them feel more compassion towards their future patients.
And there's one measurement, I think, on the quarters Chris suggested us, is that our main goal is to give them emotional impact. And if on the experience, they are frustrated enough, just put the Oculus Rift, VR device out or the AR device out, which because of the eye symptoms, which means they are frustrated enough, got the enough emotional impact that we want.
Yep.
It seems like you guys have tried both traditional tests as well as more game-oriented tests. Have you found that one works better than the other, or that one generates more interest in the subject than the other?
I think they both have pros and cons. The original one probably fit more in the AR role, that you can. It's an activity that you will interact with every daily life. And if you really use the AR device to interact it in, then it will give you a very strong emotional impact. When you try to just grab a thing like in front of your face and its double vision cannot aim it, it's quite impacting. While like for driving experience, it's just like too dangerous to do, to simulate in real life, and then we go for the VR experience.
Have you considered bringing in people with these actual conditions to speak to players before or after they use your application, and to see how that conversation goes?
For final product of our project, we are planning to send our final product to clients and to show it to clients' patients so that we can validate our content and every stuff we have.
Yeah.
Also, during our research part, we ever talk with our client and want to Skype with the patients, but actually, they have their privacy, and it seems like if you directly talk with them, it's not a good way to go.
Time for more?
Yes.
What happens with this when it's done?
Which one are you speaking of?
Whole project?
Yeah, the whole project. When it's finished, what happens to it?
It will ship to Singapore. The whole experience as a package will stay either in the medical lab, which will aim at the medical and healthcare student, or either it will go to museums as an open platform that everyone tries to experience with.
Yeah, but client is thinking of set up all this thing in his medical lab.